Okay, my outstanding friends, this is going to be a trip. This is future space, and this is called The News from CERN Just Got Weirder Than We Thought. Now, let me just play a quick clip from here about CERN. And here, I'm going to just cut in and out of this guy's video. Very nicely done.
In addition, nuclear research has been instrumental in advancing scientific knowledge, leading to breakthroughs in fields such as particle physics and materials science. So it's safe to say nuclear research has been a major boon for the Earth. One of the most valuable instruments in nuclear research has been CERN. CERN is the world's largest particle physics laboratory, and its discoveries have pushed our understanding of the universe to new heights.
Alright, I disagree. Okay, my friends, this is as crazy as it gets. Dipole electron flood theory has been completely validated by this picture alone. You see where it's coming through the Venturi, then you see all these white pulsations, then you see this black strip and this big glowing white strip in front of it. I can explain to you precisely what is happening here, what's causing all these patterns, what's causing this black, what's causing this white, what's causing these ripples. I have all the research that Rod Warren and I did, and it shows that the particles can separate. These are the electrinos turning into photons, turning into stereomuons and electron showers. All of this stuff is completely validated now. And this picture right here, this is the one. And that just came out today. That's the Venturi. This is all that concussion, the pulses, boom, boom, boom. And this is the black wave, which literally pushes the white wave in front of it. And I can prove this. And the white wave is a burner, and the black wave is the pusher. It pushes the burners. Let's see it actually happen. Alright, just to set you up for this, we're going to be jumping back and forth through this so I can show you our particles versus their particles. But here's the basis. They say a proton is like this, with a bunch of particles inside, but not a ton of them. It's called the model here. This is the standard model of the particles that are supposed to be inside of a proton. Now I say no. I say what's inside of a proton is dark matter is in the center, and all the glowy burn parts of it are on the outside. They coat it. So we never see the dark matter, but it's right in front of us all the time. Everything there is has dark matter in it, and that's the only reason these things weigh anything. Because of the dark matter that's inside, surrounded by the things that bounce back at us and cause light. That's the difference. And I can pretty much prove what I'm saying. And I certainly can stand up and talk about it because I can show we did the same things that they did, only for a lot less money. And we actually did it so that we can see the particles, not just a whole bunch of debris, like their particles. They're looking at this. They're just looking at this, and then they're picking through it and finding the smallest particles that exist. And they did. They found them. And the smallest particles that exist are right here somewhere. No, they're not. Oh, I think maybe they are. Nope, they're not. You see, I showed you, or I will show you, those Higgs fields. And these are the tiniest particles I can find. And we found those as well, only we didn't have to dig through the fields. We squirted them through a Venturi. And when they came out the other side, they came out just like this. Alright? But only they separated. We actually could separate these two. But this is a photon. A photon consists of the black muon and the electron neutrino. These are muon electron neutrino, called a Dirac neutrino. Now, when we actually concuss that, we force those particles to separate. And here's the separation right here. We accelerated it, and that's the particle accelerating and then separating the black from the white. As I showed you a second ago. And we'll go over this many times because it takes a while to understand this. This is pretty serious stuff. This pretty much shows it all at once. You've got the two particles that Fermion said are the smallest particles that exist, and I agree. Now they just see them in debris. They don't see them as we see this absolutely flawlessly. And we know this is coming out of the laser as the pulsed laser. And here's where it is coming out of. That is the particle right here. As it goes forward, it starts to manifest itself in the different neutrinos, and I will show you that as well. And then here, it actually separates into sterile muons, which is the black one, and the white one, the muon neutrino, goes into the shower mode, electron showers. This is where you get your increase, is a shower. It's not just one electron hitting here. There's thousands and thousands of them because it slams into them and showers them. So we're pulsating, boom, 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 pushing just the white through here. The black can't get through. The black is too big. It's too big. The muon is too big to get through there. So it has to go around. But in the meantime, it's just slapping the hell out of those white ones. And they're coming out of here with a vengeance, is what I see. Because anytime you see luminosity like that, that means increase in energy. That's just a fact. That's luminosity, is increase in energy. And that, my friends, is luminosity. And here's what I would think we could do, is to take that increased energy right there and put it into a thin film solar collector. These new thin films, they can collect almost all the energy that hits it. Now, coming down, it would pulse, because it's boom, 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 boom. The black ones can't get through. They are slappers. And boom, boom, boom. And they would hit this and drive through a diode, which is a photodiode. So it would take those electrons, which are photons basically, electrons, photons, same thing, almost, and drive them through into the battery. Take a little bit of it, keep it running, and we should get a ton of free energy, because there's nothing to do here, there's nothing added, it's all solid state, very, 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 very simple. So now, let's get back to CERN and see what they have to say about the research they're doing. So here we are. We're going to back to checking out CERN. Here goes.
Its behavior. To this day, CERN hosts some of the most advanced scientific instruments ever conceived, which allow scientists...
You see this? That red particle coming through, and they're watching it cause disturbances in the air. Let me show you ours. This is our red particle coming through the air. You can see it there, but let's see it in greater detail. We can see it right down to its exact flow, and this also shows the neutrinos. All right, what you're looking at right there is the photons. Remember the photons? And they're green, they're blue, they're red, they're the same in all colors. However, they're more spin rate. The red is just a very slow spin rate, which gives it a long frequency, a long wavelength. But coming in, you get a certain type of a neutrino, and which is not quite the same as this. And it's also not quite the same as this. That's why they say they change flavors as they move. So you pick up a neutrino out here, and by the time you get down to here, it's all kinds of different neutrinos because it's stacking up on itself. This is in the photon phase, and that's basically light. That's light. And you would really never see it because it's like up in here there's light too. You just can't see it. It's starting to illuminate itself and to expose itself and to manifest itself as light enough that the CMOS that we used in the smartphone was able to detect that increased energy. And that's the only reason it's increasing in energy, because it's about to explode over here. The light up here, there's the same particles, the exact same particles coming here, are up here, but they're not accelerating. Here they're starting to get compressed a little bit like they are down here, because this whole wall is flashing back at it when it explodes here. You see them right here? The whole wall pushes back. That's called reverse EMF, and I can show you that very clearly. But these are the particles, the black and white particles. So what we're seeing is that red particle going through the air. Now let me show you even better than that, is the single particle. Hold on one second. Alright, this is kind of crazy, but it's true. This is what they show for the Higgs boson at CERN and Fermion and so forth. And what they're doing is smashing these huge particles that have all these different colors because they have these different energetic values. And when they spit out, mostly the red just sort of stays together because it's very weak. The other ones are real powerful and they take off because they're smashing head on two particles. Big ones, huge ones. Boom! And they go flying everywhere, bits and pieces. We are going one direction with one particle, one light source. And here's what we get for our Higgs fields. Remember what those look like. Here's ours. That's our one collision. All right, they're colliding two particles like this, and they get all kind of stuff. We're coming in like this, and our product is the Higgs fields. And we can do this all day long. We can squirt them all day long. And the green is exactly the same thing, only much more powerful. You see the green, very much more powerful than the red. And of course, there's their Higgs fields, and these are our Higgs fields. And what else can I show you? I guess that's about it for the moment. Alright, I just showed you the Higgs bosons, and they call that the God particle. Now listen to this now.
While the title was changed later on, this phrase highlighted the frustration that scientists felt towards not being able to explain how particles get their mass. It has also sparked debates among those who consider religion and science as two separate entities, with some taking offence to assigning a divine connotation to the Higgs boson particle. The discovery of the Higgs boson particle by CERN's Large Hadron Collider, LHC, on July 4, 2012, was a major breakthrough in the scientific world. This gave us an insight into the origin of mass and is made possible by the Higgs field, which acts as an invisible energy field that permeates all space, giving particles their mass, just like gravity. This Higgs field is an internal part of the standard model of particle physics and is a crucial step toward understanding our universe. Without it, we wouldn't be able to explain several phenomena observed in nature, such as why certain particles have mass while others don't.
Alright, and that's what I showed you, was the white and the black particles. The white ones have no mass at all, and the black ones have mass. And I'm going to show you one more time. I've shown it dozens and dozens of times. Atomic bomb blast displays this perfectly and completely validates my electron flood theory. Okay, once again, exactly what I've been saying is that there is dark matter, and it's completely coated with particles that will glow. The dark matter doesn't glow. It's on the inside of all the glowing particles, and they always go to the outside. They get pushed away and push the dark to the center, as I showed you in space, which everything is in space. Literally, it's in its own space. You see the Higgs fields, the green is the same as the red. And this is what happens in space. The charged particles will surround a black hole. And this is the same thing that happens in anything that's the size of a proton and up. Is that the dark matter is going to go to the center, and it will be just like this, completely coated in particles that will glow back at you. When light hits that, they glow back. What's inside there doesn't do anything. It's completely black, but it attracts these to the outside of it. So what is an atomic bomb? An atomic bomb is nothing more than so much material in one place, in one small package, that when it goes off, it's a nightmare. And when it goes off, what it does is, when I say goes off, here's what they do with an atomic bomb. They have so much mass here that it just wants to fall apart. And then when they collapse it, it pushes back out so hard that everything goes. Now, what will happen when everything goes? The outside crust is going to go first. That's the white particles. They have no mass whatsoever to speak of. And that's what Don Lincoln says at Fermilab. Here it is right here. This is zero size. All right, the extended particles have a fixed size. That's the black ones, and I'll show you those in a second. Although they may have a fuzzy edge, that's just a color. The point-like particles are mathematically zero size. They have no size. There was no mass. But they have an extended effect due to the effect of the field surrounding them. Extended. Not just tiny, extended. And that's what happens. These go first, and they hit the house. All right, this is atom central. Now, I got it down to 25%. What's going to happen is the bomb's going to go off. The white particles are all the electrons. They have no mass. But the field interacts with every other field, and it just makes everything just vaporize. That's what it is, it vaporizes. Then the black particles come from behind. So we're going to see there's two separations, and the white ones are always on the outside. They go first. The black ones come second. And here it is, that actual event occurring. All right, the first thing you're going to see is brilliant white. And everything, that's the white ones come, and they're going to be coming through the air. Now, they're interacting with everything. They're not moving anything. Nothing's moved. It's just all burning up because of the interaction of the fields. Now the black ones come from behind, the big black ones, and they take the house and just smash it to bits. No more burning. And then it all turns around and comes back. So this is the craziness, that it weirder and weirder and weirder day by day. Okay, my friends, major shocker. I just saw on Rod Warren's channel that he posted these pictures here of, apparently he's back doing some more light research. I thought I lost Rodney. This is a very happy day for me. And what I saw from these pictures is going to knock your socks off. Did me. Now let me show you what we used for the last 6 or 7 years, or maybe even more than that, was a Samsung Galaxy S3 phone using the selfie side to take pictures of all of these interactions. Rod did all the work. I can't take credit for it. I have all the same stuff, and I did some, but nothing like Rod did. Now, this is basically, that's it. This is what we used. That's it. This exact same laser, pulse laser he used, which is a construction laser, bump, 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 and it measures the distances. And then 2 literally finishing nails. And then other little lasers, and that's it, and the phone. That's it. That's it to do all this work. Now let me show you. I got that laser right there pointed at my book over here, and then I'm going to show you how the laser spreads out and gives the what they call the interference patterns. Now I've been showing this for years and years and years, at least 6 or 7 years. And I'm showing the black and the white particles, and then I'm showing them explode here at the Venturi. Of course, again, this is what Rod did. This is not my work. This is from Rod Warren. And he proves my theory. Thank God somebody stepped up and did it, because I knew for a fact everything had to be a dipole. It has to be. You can't make a big gigantic proton and one little tiny electron. It just doesn't work. They come right together. Anyway, I've known that, and I wrote that years and years ago. And that's what got me out of physics, because not a single person would listen. Anyway, now we're seeing the black separate from the white. All right? And here is that acceleration happening right here. And that's this event. Now, what is happening there? Why are we seeing this white? And what is this black spot here? What's going on with that black? Wait till you see what he showed me this morning, or what he's put up on his site this morning. I haven't talked to Rod in a long time. I thought I lost him. And I hope this is Rod, and I hope he's back in action here, because I tell you, he should be going down in history. For the first one that's ever seen dark matter. That's dark matter. He's the first one that's ever seen a photon. That's a photon. He's the first one that's ever seen electron neutrinos. And you know, my work is in atomic flood theory. This is my dipole atomic flood theory, which everything is an electron. Basically, everything's made out of electrons, this black and white particle. One of these together is an electron. Two of them back to back makes a photon. An electron, one of them, will burn into you, it's electricity. Two of them back to back will bounce off of you, they're basically neutral. One of them says, I want to really be attached to something terribly bad, and it will stick to you as static electricity. It will come down to lightning. If there's enough of it, it'll go right to ground. Ground is loaded with this dark matter. Ground is completely saturated with this dark matter. That's what makes it so attractive to the white particles, which are lightning, static, electricity. You always have to go to ground. You ground it so it will go around you and go into the ground, because the black wants it so much more than any other particles in the air, because they have both sides already. The black, right down. And if a water pipe in a wet condition will accept more and more of that electricity. If you put a pipe into an insulated spot in the ground, it wouldn't conduct the electricity. It needs to be hooked into the molecules that are touching this dark matter, and this Earth has to be completely saturated with dark matter. That's the only thing I can assume. And I showed this in space. Hold on a second. I think I have it here. I may not. I do not. Hold on a second. All right, here's my claims. I'm going to show you this actually proving about the black and the white particles, proving that the black is just a pusher and it's a fixed size, and the white can get really glowy and burns, but it has no mass. Now, all of this we did was with this exact equipment. That's all it was required. A couple of little pulse lasers, and that's all this is, a construction laser. This was done with a construction laser right here. This Bosch laser, same one. And it was shot through a Venturi. Now, how Rod did this one, I'm not exactly sure. We really didn't communicate too much. He would just send me pictures, and then I'd try to figure out what was going on. And I spent a lot of time. We spent years and years doing this. Now, so what is he looking at here? The dark particles here are pushing the white particles ahead of it. So what are the white particles glowing so much for? Because they are hitting ahead of them. There's a whole batch of white particles that are in the air, which are gases and moisture and all that stuff. And they have to get through it, which I show you in this other one, which is light just coming through the air, unobstructed. You see that? There's no Venturi here yet. It's heading towards the Venturi, but this is just getting ready to head towards the Venturi. So it's picking up speed. But you see all this concussion in front of it? Now, at some point, it's going to look just like the other one Rodney had after it goes through the Venturi. And here's the Venturi. So here's the particle wave that we saw before, and the particle's in there. And it starts to speed up and pull itself right out of the magnetic wave. That is so fast, I can't imagine how fast it is, but it's way faster than light, obviously. Now, what happens here? An explosion, a literal subatomic explosion. The white particle separates from the black and squirts right through the Venturi. And it appears, from what I'm seeing on Rod's picture, right over here, the black starts to grab a hold of the white and continues to push it. That's what it looks like to me. Remember what you're seeing here. Now let's go back to the Rod's shot, this one here. It came out of here, and right in here is all that white stuff. There's nothing but white. Now, he's got a different look to it. I don't know how he did it, but you can see it's pulse, 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 pulse. But there's nothing but white here. Somehow he's got, I don't know how he does this stuff. I really don't. That's why I gave up. You know, Rod was sending me pictures. I just couldn't keep up with it. And it's just absolutely freaking phenomenal what he did. But this black is the black part of the particle, the black and white particles together. They were separated, only the white came through. Somehow now, brown cow, that black stuff is back here. I don't know, how did that happen? We know when it came through there was nothing but white. I can see little spritzes of black here, but this is literally only white, and all of a sudden, boom. the black shows up. How did that happen? Where'd it come from? I got some serious questions here, but I also got some serious answers. Now, like I said, everything that was done here, with all of these pictures, this and all of these other ones here, these are all real pictures. These are not, that's CERN, that's a little doodle type picture. That's CERN, another doodle picture. All our stuff is real. That's another one from Fermion, but it is real, the black and the white particles. I showed you those. And here's the black and the white particles from Fermion, and they actually saw those, and these are those particles. So Rod did all of this stuff, and we came to a conclusion of what the particles actually are made of, and they are the same particle. Green is the same particle as the red, which is the same particle as the blue. All right, here's the red. All right, and this is exactly identical to what they say from Fermion. And this is why this one glows, because the black is pushing it. Now, the picture that I'm showing though is all black and all white in front of it. And that's because it's slowing down after the Venturi. Because it's highly accelerated here. I mean, extremely accelerated. And then you get out to this area, and somehow that black comes back in. I got to figure that one out. But everything we did was done right here with this. Everything. The only thing else Rod used was some different glass, different types of glasses. He was using the bottoms of bottles and all kinds of things with bumps on them. And I mean, he was doing stuff that nobody in the world, he was doing water and I mean, all kinds of things. But this is just phenomenal. And I'm going to explain to you those pulsations and why you see them all white here, pop, 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 and then all of a sudden it turns black with the white wave in front of it, and then you see more pulsations out here, and then you see them to start to actually get very long. They're shifting to the red, more length on the frequency. That's because they're slowing down. Okay, this is Rod Warren's channel. Here's Rod Warren on YouTube. And here it is looking at light passing through the slits. Now, I don't know if he used one slit, two slits. It looks to me like he's still staying with the single slit. That's what we always use. Now, again, I haven't heard from him in quite some time, so I was really surprised to see this show up. And Rod deserves credit for absolutely stunning work and dedication to it. Never wanting to receive anything. He's a quiet guy. We haven't spoke probably 50 words between the two of us over the time. You know, a few emails back and forth, but basically he just sends me pictures like this. There was no real discussion about it. And I'd ask him, can you try this, can you try that? And he did it. Oh, he did everything that I ever could have asked for and more. And again, this work is stunning. It's absolutely stunning. This is what they should have been doing at CERN. They should have been looking at, you know, and I did. I presented this to the University of Geneva. I went there for particle physics. I showed them all that stuff. And I think they paid attention because not long after that, they upgraded the CERN super collider to focus like this and to use CMOS to see these interactions rather than putting something in there that extracted some of the energy and caused bad results. That's what the observer effect is. When they put in something that interacts with the fields, you lose all kind of problems show up in there. They say every time we look at it, it goes crazy. Well, you're putting something in there that interacts with the fields and absorbs them. All we're doing is looking at the radiation. So he could be way back here, he could be right in there, it doesn't matter. Because all we're doing is seeing what's coming, being shot out of there. And Rod's got the way to do it right there. And now they are doing it the same way at CERN, and they're finding all of the same kind of particles we found, only they're finding them in debris like this. This is what they're finding, it's just pieces all over. And they look down and say, ooh, look at that little bitty one. And this, is what they've been doing for research for years. They're still doing the same thing. All these particles at the same time. So they have all the different colors. We're just using one color and seeing it as light instead of crashing huge particles together. These have 1823 particles in every proton. We're using 2 particles, which is a photon. Okay, so what are you looking at right there? You're looking at an atomic, subatomic explosion. Right there is just pretend this is an atomic bomb. When it explodes, as I say, all the white particles go first. There's the white ones, and the black ones push them out. When it hits the house, which you're going to see in a second, the white ones just burn it. And then just after that, these come and they knock the house down. The black ones are nothing but bowling balls, and these get real glowy, and they burn. And we're going to see that right this instant. Okay, once again, atom central. I've got this down at 25%. The first thing you're going to see is going to be the white particles shedding out. So the atomic bomb is here. Out come the white particles. And all they do is burn stuff. They don't push anything away because they don't have any mass to them. And then behind it comes the black, and the house goes flying. See? There it goes. So there was the black. The first was the white, then comes the black. Now it starts to come back because there's a void now where the house used to, where the bomb used to be. All right, so one more time. Remember, these are all the white particles that were ahead of that wave. And everything that's out here is going to be burning the same as this, even the wires and everything. The poles, they're all, anything that has combustion ability goes. And then the black ones come and they just smash the heck out of everything. Okay, I want some engineers, some really top-end guys to get a hold of me. This is just like an atomic explosion, only subatomic level. These are the explosiveness coming out of it, and the black is pushing the white. That's what they call the carrier boson, and these are the fermions. The fermions glow and burn, and the carrier boson is just a pusher. It pushes, it just shoves them. And then they glow like crazy. These are much more intense than the black. The black has no intensity to it. It's just like somebody pushing snow, like a snowplow. You see, this is cool. This is water in space. This is by plasma Ben. It's only very short. Listen to this.
A rotating sphere of water about 25 millimeters in diameter, and inside this sphere are a whole bunch of little tiny air bubbles. And we will see what the angular acceleration due to rotation does to these air bubbles as a function of time. What you are observing are the bubbles moving to the center axis of rotation. As a function of time, they will form this rather tightly packed bubble core. These bubbles are kept from coalescing from a small amount of added surfactant to the water.
Surfactant just means that they can't turn into just one big bubble. But that's what would happen.
Here we have a rotating sphere filled with bubbles and tea leaves, and as expected, the bubbles go to the center and the tea leaves go to the outside edge.
Does that remind you of like anything that we might be living on? That's what's happening. That's in space, and that's why water doesn't go flying off like the flat earth people say. It's in space, it's a whole different issue than it is here on Earth. Well, it's really not a whole different issue, because Earth is nothing more than a ball in space, just like that's a ball in space. It's all it is. All right, I think I've shown you some of the pictures about this, but this is the actual experiment in space. This is 15 years ago. Oh, no, 7 years ago it shows, but this was, I guess, yeah, it was 2015. And this is out in outer space. They have a full-size vacuum chamber. Well, full-size, I say it's a nice little small vacuum chamber out there. And they are going to put in charged particles. You see these charged particles? Boom, here they come in. All right, see them all streaming in. They're setting up a line. That's because they're pushing and shoving. You see them setting up a line like that? Now, they're going to collect, they're just going to sort of swirl and do all kinds of things. And eventually they're going to settle into a pattern, which is a black hole. Now, they had thought they were going to make straight up and down lines like this eventually. But no, they started to do all this stuff, and then they started to create a black hole, and it freaked everybody out on the Earth because nobody had expected it. And I never expected to see the black separate from the white either. That was a total shock. And see what happened in space? There it is right there. And the reason it's bouncing up and down is because there's a wall up above and a wall down below. So they're bouncing up and down because these are the pushy particles. And eventually they'll all sort of crust around the black hole, just like they do around the Earth. Watch it bounce up and down. See, bum, 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 bum. That's because they're vibration of their fields. All right, this makes sense. No, this is about finding the Higgs field, which I just showed you. And again, the problem is they're smashing things head to head.
As an amazing breakthrough, it also raised more questions among scientists. For instance, we still don't know why the Higgs field has the strength that it does, or what caused it to take on this form in the first place. The discovery of the Higgs boson, sometimes jokingly referred to as the God particle, was an incredibly important milestone in physics.
Here's the problem. When they're hitting them like this, everything goes flying everywhere. It's just smashing to bits. And then they dig through and they say, ooh, look at that little tiny thing. Well, we started with light, which is an elementary particle. That means it cannot be broken down, although I have shown it can be broken down and separated from the muon neutrino and the electron neutrino, because that is what light is both of those two particles together. So this is why things are getting weirder and weirder and weirder. And I'm showing, the particles I'm showing are the particles that they're showing at CERN and Fermion. These are the two particles, these are the two particles, there they are. And we separated them, we did exactly what they want. That's exactly what CERN and Fermilab are looking for. The muon neutrino, electron neutrino, turn it into a sterile muon, a black ball, and a white shower, the white shower. All right, that's light accelerating. So we broke all the laws of physics. The laws I don't go with. You know, that's the problem. Oh, you can't do that because it breaks the law of conservation of matter or whatever it is. It doesn't matter. And sometimes maybe the law works. I don't know. But maybe there's a different way of looking at it. Maybe the conservation of matter is the black and the white. Nobody ever knew about the black was attached to the white. Nobody knew that. Nobody's ever known that. That's why an electron is not just a burny, glowy part that does electricity. It's attached to a muon, the two of them together. And that's their nature. Now, they can separate, and when they get into massive balls, I believe the center core is black on literally everything. And that's why we've never seen it, because it's only surrounded by things that bounce back at us that we can see. That's the bounceable particles, and these are the bounceable ones. And they will always surround the black ones.